Hello and welcome, and thanks for joining my session on KNX and wireless mesh networking. My name is Finn Boetius. I'm a product marketing engineer at Nordic Semiconductor, but actually more fitting today. My name is Finn Boetius. I'm a master craftsman, electrical engineering craft, and what you see here on this picture is exactly what we're trying to avoid. Opening up the walls to put a new electrical installation. Because today we're going to talk about wireless mesh networking, KNX IoT. I'm going to give you a bit of an introduction into Nordic Semiconductor, into the thread mesh networking protocol, and I'm also going to show you a demo where we have complete wireless light switches and light bulb that work with an existing KNX installation. So stay tuned for that one. So Nordic Semiconductor, we are leading IoT enabler. What does that mean? We are fabless Norwegian semiconductor company, which means we make computer chips basically. We have about 1,500 employees, and we just celebrated our 40th birthday. We are leading in ultra low power wireless, and that's what we do, and that's also why we got asked to get involved in KNX IoT. We are mostly known for our Bluetooth Low Energy product, but we are also in applications like Zigbee, Thread, Wi-Fi, and this is LTM and NB-IoT. Those are low-power cellular solutions. As I mentioned, we are mostly known for Bluetooth Low Energy. Let's have a look at what this looks like. So this is all Bluetooth LE and product certifications. So Bluetooth LE products that got certified. And this is a look at last year, but this looks similarly every year. These are devices using Nordic hardware, and this is our second biggest competitor. And this in itself seems pretty impressive, but it's even nicer if you think about that most of these companies have 4 to 10 times the amount of employees that we have. And one thing that I didn't mention on the slide before is we are about 1,500 employees, but most of those, so about 75% of us actually work in research and development. So we are basically just an engineering company. We make hardware. And one very important thing if you're in one very important thing when it comes to wireless IoT is standards. So we are involved in a lot of them, but the two that are important today are the Thread group, and here we are a board member, and Thread, we are talking about Thread today because Thread is the foundation for KNX IoT. And we also recently joined the KNX Association. Before we go into the details of what Thread actually does, just a very brief overview of Nordic and Thread. We are very experienced when it comes to Thread, so we joined Thread basically when it started being a thing. So right from the start of its public existence in 2016, we started working on OpenThread. We also had the world's first certified component using OpenThread. We are market proven, so there's several well-functioning products out there that are using our hardware and software. And that, for example, most of those use cases are in smart home at the moment, because that's where Thread got big, because of companies like Google, Apple, and initiatives like the new Smart Home Meta initiative, for example. And there are lots of working products out there, so we are market proven, our products work. And of course, we are actively improving. So OpenThread is constantly being developed and improved. If there's a security risk found out, which always happens with every technology that transfers data, it's going to be fixed very soon. And other than just fixes, the Thread as a technology is also constantly improving. And some of those core modules are co-authored by us, next to companies like Apple, like Google, like Samsung, and so on. So yeah, you are definitely listening to the right company here. Then now let's have a look at KNX IoT and Thread. I'm assuming you also already know the basics of KNX IoT, so I'll be going more into what Thread actually is. Let's start off with some challenges that wireless KNX has. We have several implementations of this. So for example, KNX RF, which works, and it's a wireless standard for KNX. But it's limited to Europe, it does not support IP networking, and it also does not support mesh. And then there's KNX Net IP. The main problems here is it's not low power, and it's not actually meant as a transport from sensors or actuators. So it's not ideal if you, let's say, want to have communication between a light switch and a light. That's not what KNX Net IP is meant for. It's meant for building a baseline, or it's meant to be a baseline to build a network backbone. In comes KNX IoT over Thread. This is, I've titled this Low Power Revolution, but it actually is. So if you look at it, Thread is a very modern solution. It runs on the global ISM band, 2.4 gigahertz. Which the biggest advantage is these are the same frequencies no matter where you are in the world. It is IPv6 based mesh networking, and if you look at battery operated sensors, for example, these can last for years with a single battery charge compared to possible like months that would be possible with KNX Net IP. And KNX IoT, as you can imagine, has great potential in retrofitting. Just if you estimate the cost of adding a new sensor, a new KNX sensor to an existing office installation, it's not very unlikely that you're going to be in a couple of €1,000. So in this case, we estimate about €5,000 when you can do the same thing with a wireless installation for about 500. I mean, obviously, in this case, the main cost here is like getting open the walls, putting in your twisted pair installation, closing up the walls again, doing your installation, and also getting a painter in afterwards. So you can see how it would be a lot easier to take a battery-powered device, add it to the wall, and include the new device in your existing installation. So let's talk about what Thread actually is. Let me try to give you a very high-level explanation. I'm gonna try to make this as simple as possible. So what I usually say is Thread is a mature and proven technology that keeps improving. The thing you have to keep in mind is it works. It is being used and it works really well. If you want to take a look at how well it works, the best way to get a feeling for it is check out devices that now work with Thread that used to work with something else and read product reviews. In 9 out of 10 times, the reviews will say it's a massive improvement. I think, don't trust me, just Google it for yourself. And this is also really easy to find reviews because a lot of the Thread-based products at the moment are consumer products. So this is really easy to figure out yourself. And it has IPv6 based networking. What this actually means in practice is that it gives every device its own address. So let's say your installation has a cloud integration. It's a lot easier for the cloud to communicate with a specific device. So there's no extra step in between where it has to translate between the physical address of the device and the address you give it in ETS, for example. And it's a scalable, self-healing mesh technology. What this means in practice is, let's say you have several devices. One of those devices would be a repeater that repeats the signal to the next device, right? That's how you would do it for Wi-Fi, for example. Your Wi-Fi doesn't have enough range, so you put a repeater in to reach the faraway devices. How it works with mesh technologies is that most of the mains connected devices, this could be, for example, a light switch, this could be a light, this could be a device that's in a wallbox installation, right? Most of these are router-capable devices. So let's say one of those fails. Another one can take over. So the device that was just an end node a couple of seconds ago now works as a router because it needs to. And all of this happens automatically. So it's a really, really well thought through technology. And I put this here, a trigger warning for embedded engineers, because I have even more high-level explanation of how you can think of threat if you just want to explain it to somebody who really doesn't care about technology in general. They just want things to work. You can think of a very low-power wireless local area network, like your home Wi-Fi, but in this case, most devices can work as your repeater. And if you need to explain threat in one sentence, you can use this one. If somebody complains, you can send them my way. No, but yeah, this obviously is not entirely accurate, but it's a way you can think about it. So I want to show you here how a threat network could look like. In a threat network, let's start all the way at the end. So these are end devices. These would be the most low power devices you have in your installation. And this could be something like a sensor that is just placed somewhere and it only needs to send information a couple of times a minute, for example. So these are end devices that can run for a very, very long time. You can just put it in like a fire alarm, for example, right? You just mount it at the ceiling and it'll last you for 10 years. Devices like this are possible to be included in a KNX installation wirelessly and on a battery. These devices, how do they actually get their messages? They would communicate to a thread router or communicate with a thread router. And if you think about your installation, let's say these devices, let's say this is an occupancy sensor, this could be a light or a light switch, and this could be some device that's installed in a wall box somewhere. So routers are usually mains connected devices because they need to route the information. But you know how many of your devices are connected to mains at the moment, right? The big advantage here is you don't need to have your twisted pair going all the way here. You just need power. And then every thread network will also have at least one, but it can have as many as you want, border routers. And these are the gateway to the outside of the network, basically. So let's say you have a cloud integration. The border routers are gonna be the devices communicating with the internet. And the great thing is, if a device here fails, another device can take over. Let's say this border router fails, no problem. Well, it's a problem because the device doesn't work anymore. But the rest of the network doesn't have a problem because of that, right? So then this border router could take over the functionality. Let's say this router would fail. If this were a wired system and you would have a cut wire here, all of these devices wouldn't work anymore. If it's a thread device, what would just happen is this router, for example, could take over the responsibilities. So the border router would communicate with this router with this router, and so on. And this happens automatically. So if one of these devices fails, or you need to exchange a device in your existing network, the network reorganizes itself to work again. No extra input needed. And this also means, let's say you put in a new device somewhere, and this would make a different path easier. Let's say you put a router that's like spatially here, right? It could reroute the signals from this router would go here and exactly to this end device. So the network organizes itself as efficiently as possible. It's always trying to reduce the amount of hops a message needs to take. So I hope you're still with me, because now we're gonna go to what Nordic actually has to offer KNX. And as I mentioned before, we are a semiconductor company and we focus on low power wireless. So what we have are semiconductors, it's ICs, and they're meant for low power wireless. This is already a very high level explanation, but we're gonna make this even simpler. It's a computer chip, it's a microcontroller that has a radio integrated. And this radio, in both of these cases, supports Bluetooth Low Energy and a thread radio. What's really great about this is, let's say you have a system integrator or you have somebody who has to install a new device. By using this chip, you already have Bluetooth Low Energy integrated in your device. And both of them are using 2.4 gigahertz. So this is not a significant extra cost involved, right? But it enables the installer to easily connect to the device itself and put in some parameters, for example. And there's different devices that I think I'll go a bit more into that in my next slide, because here we talk about the actual development hardware. So if somebody wants to build a device based on our hardware, the way they would start is you would take one of the development kits. It has the IC on it, and this would be the IC itself. And all the functionality of this chip is broken out to different pins here. If you're not a company that builds devices themselves, you don't need to know this. The important thing is the companies that do build devices themselves have a really easy way of starting to build devices based on Nordic. So this is the baseline device, basically. So this is the NR52840 and this development kit. So this is the development kit for that device. And this supports Bluetooth Low Energy and thread. Let's say the device that you want to build is a bit more complex, so it actually needs to process some information, do some calculations on its own. Then we have one step up, which is the NF5340 development kit. It also supports Bluetooth Low Energy and thread, but it has more processing power, it has more RAM, and it has more flash. And we also have solution to add an extra chip next to it to add Wi-Fi functionalities if for some reason that is what you need in your design. And I'm also gonna show you a demo that we built on our own for KNX IoT, all completely wireless. And the device we're using in there is our Nordic Thingy 53. It looks quite big here, but in the video you'll see that it's actually relatively small. This is what we call a prototyping platform. So we build a device that has the NR5340 SoC in it. It has an extra front-end module that gives you even more output power. And it allows Bluetooth Low Energy. It also supports Bluetooth Mesh, for example, which is also interesting for building automation. And it supports thread, which is the important thing today. And this has several sensors included. For example, there's also a gas sensor that can detect volatile organic compounds, for example. There's an accelerometer. So there's lots of interesting sensors in here. But the interesting thing is, like, this is basically a really nice tool that you can use if you want to build your own prototype. And it's fully supported in our software development kit. And what I want to show you now is how we can use this thing as a light bulb and as a light switch together with an existing KNX installation. So what we see here is our current demo that we have. We have a very simple installation. It's an on-off switch. We have a power supply. We have a KNX IP router, an actuator, and some indicator lights. And we have two Thingy 53s. One of them is going to be used as a switch for KNX IoT, and one of them is going to be used as a light. And we have a switch. So if we switch it on, normal KNX installation, use the switch, switch off a light. But the exact same thing works wirelessly. And also, we can still use the switch, but this one works as a light bulb and is also controllable by the wired installation. So this just as a very brief proof of concept. And the samples for all of this are available. So if you are interested, you can get into contact with us. So let's summarize a bit. What is already there today? We have an experimental implementation of KNX IoT in our GitHub repository. The results of that you just saw. We have full feature development kit that enable development. So a company that actually builds KNX devices can get in contact with us, and it's relatively easy to develop devices. And we have a Thingy 53 prototyping platform, which is the little blue devices that you saw in the video that are really, really nice to build prototypes. And we have a mature implementation of Thread in our NF Connect SDK. And why are we actually here today? Because most of you probably aren't device manufacturers. Most of you are system integrators. So what we wanted to show today is what is possible using KNX IoT. And what we want to do is we want to cultivate device manufacturer partnerships. So we want to work together with the device makers that build KNX devices to enable device manufacturers to build good and reliable KNX IoT products. And then you might be asking yourself, what can you do? If you're system integrators, let your suppliers know that you're interested in KNX IoT. If they get the information, it's a lot easier for them to know that there's an interest and they're going to start producing products. If you're a system integrator, the best thing you could do for us and the best thing you can do if you're interested in KNX IoT is let your suppliers know that you are interested and that you're looking forward to get good, working, reliable KNX IoT products. And you can let them know you saw a very great presentation from Nordic Semiconductor. And if you're device manufacturers, it's very easy. Contact us, let's talk, let's see how we can drive this forward and get your KNX devices or your KNX IoT devices to the market. And one of our main goals as a company is we want to excite developers. So we have a very great set of tools to make it easier to learn how to work with our products. We have an academy that explains the details on how to build devices based on our products. We have a really great tech support community with over 50 application engineers exclusively there for technical support. And we have our own webinar platform where we talk about technologies and, for example, things like KNX IoT. And with that, I'm done for today, and I want to go over to the Q&A. So I'm looking forward to your questions.